Hey guys, how y'all doing today? In today's lesson, we'll be writing one variable equations or inequalities. Let's go over some definitions real quick. Sorry about my phone. Alright, an equation is a mathematical statement composed of algebraic and or numeric expressions set equal to each other. Once again, so equation represents something being equal, so it can represent with an equal sign. What's going to be an algebraic or numeric? So for example, when they say numeric, it could be like 5 plus 3 equals 8. Algebraic, they're indicating something like 3x plus 2 equals 10. Just an example. Inequality is a mathematical statement composed of algebraic or numeric expressions set apart by an inequality symbol. So same thing basically as an equation, except this time we're using inequality symbols such as greater than, less than, greater than or equal to, less than or equal to. Okay, a variable is a letter or symbol that represents a number. Okay. Once again, like an equation example right here, and in the inequality example, we have variables as, well, in this case, we're letting it be x. Okay. And a variable is any letter. It can be A, B, C, D. It doesn't matter. X, Y, Z. It doesn't matter. It's just a letter that's representing some number, some unknown number. Okay. And once again, it can also be a symbol. Usually you don't use symbols early on in algebra. We use letters. But you can use a symbol as well. Coefficient is a number that is multiplied by a variable. So like the examples show here down below. In this case, 4 is a coefficient and 3.2 is a coefficient, as they're multiplying to a variable, in this case x. Once again, when numbers are right next to each other or numbers right next to a variable, they're indicating multiplication. Okay, in this case, our coefficient is 1 over 5 and 4 over 7. Once again, they're right next to that variable, multiplying to that variable x. A constant is a fixed value that does not appear with a variable. So it's just like some known number, and we're not multiplying to any number, or it's just some known number not attached to a variable. So in this case, it's a constant is 12 and negative 4/5. Once again, you can see that they're not attached to a variable. Inequality, negative 6 and 2 are our constants. Equality and inequality words and symbols. Okay, we'll just make sure we understand. Equal to is represented with this equal sign right there. That's a symbol. So in words, we say x is equal to 4. How it looks in symbols is x is just equal to 4. Greater than, well, we have like this little alligator mouth opening up. X is greater than 4 in words. Symbolically, it's x is greater than 4. Greater than and equal to, well, same thing, alligator mouth opening up. Now we have a line underneath it. That underline underneath it means we can be equal to that number as well. So x is greater than or equal to 4. So symbolic, once again, x is greater than or equal to 4. Once again, this is indicating that we can be the number 4, but also anything greater than 4, like 4.1, 4.2, 5, 6, etc. Less than, indicated with the little alligator mouth pointing the other direction. So in words, x is less than 4. So symbolically, x is less than 4. Once again, that's indicating that we can be numbers like 3.9, 3.8, 3, 2, 1, 0, negative 1, etc. Just can't be the number 4. But anything less than, we're good. Less than or equal to. Once again, alligator mouth is going in the other direction. X is less than or equal to 4. So x, once again, the alligator mouth eats the bigger number, so the bigger number is 4. So that's why the mouth is opening up to the 4. But once again, we are less than or equal to 4. So we can be 4, but of course all numbers less than 4 as well. And then not equal to symbol. Once again, we represent that with an equal sign with a line going through it. So x is not equal to 4. Well, same thing symbolically. So that's what it's saying. X is not equal to 4. Let's not forget our order of operations, which are the rules of which calculations are performed first when simplifying an expression. Usually we use what we call PEMDAS, where we go parentheses and brackets first, then exponents, then multiplication and or division, and addition and or subtraction. Okay, let's look at some problems here. Once again, in today's lesson, we're just going to be setting up the equations or inequalities. We will not be solving yet. So, let's look at this first one. It says, Tanya must choose between two job offers. Job offer A pays a flat rate of $22.50 plus an additional $9.77 per hour. I'm going to tell you guys now that per or each word usually indicate a variable. Not always, but usually indicate. Job offer B pays a flat rate of $9.95 plus an additional $11.40 per hour. Write an equation to find the number of hours worked H, at which job A will earn the same amount of money as job B. So once again, we are letting the letter H represent the number of hours. So on job A, once again, it pays $9.76 per hour. Once again, H is representing per hour, plus a flat rate of $20.50. And we want it to equal job B, where they pay $11.40 per hour, plus $9.95. Okay. I'm going to do some more examples after this. I'm going to write them out, but let's go through these pretty quickly so this video is not too long. Alright, the perimeter of the first figure in the sequence above is 3. So 3, perimeters 1, 2, 3. That's not the number of sides of perimeters. I guess they're just assuming that each side measures 1. Using the sequence, write an equation to determine when the perimeter of the figure will be twice the position in. Okay, well we can see we're assuming each side is measurement of 1. So 1, 2, 3, that's the perimeter there. Next figure we go 1, 2, 3, 4. And then perimeter be on the next figure 1, 2, 3, 4, 5, and etc. So for each triangle or in each new figure, we bring in the perimeter increases by 1, which is kind of shown in this chart. Position number 1, perimeter 3, 2, 4, 3, 5. So we're just taking our number in, and to find the perimeter, we're just adding it by 2. Notice 1 plus 2 is 3, 2 plus 2 is 4. Therefore, the equation that we're looking for is, well, the perimeter, n plus 2, we want it to equal, once again, twice the position number. So, twice the position number, or n represents the position of the sequence. I know that one's a little confusing, so if you have questions on that one, come see me for tutorials. Alright, kind of the same thing we had up above earlier, but this time they want us to write an inequality, find the number of hours worked H, at which job A will earn more than job B. So of course job A was represented by that $9.77 per hour plus the $22.50, and we want it to be more than, so greater than. So we're going to open the mouth to it, to job B of $11.40 per hour plus $9.95. Okay guys, like I said, this one's a little confusing, so I'm going to move on to some of these sample problems that I have. And let's talk about them. So it says Rhonda bought 5 shirts from a store and had $10 left. If she had only bought 3 shirts, she would have $24 left. If each shirt costs the same, which of the following equations could be used to determine X, the cost of each shirt in dollars? Real quick, we're going to let X represent cost of shirts. Alright, well to solve this, we know that if she had about 5 shirts, or put it this way, we know 5 shirts, or the cost of 5 shirts plus $10 is the total amount of money she had. Because once again, she was able to afford 5 shirts, but she still had $10. And then we know that she was able to buy 3 shirts, and she had $24 left. Okay. And once again, when she bought 3 shirts, she had $24. That's the total amount of money she had. So, if each shirt costs the same, which of the following equations could be used to determine X? Well, we could use the equation. We could use both these guys to help us out. Because I know that when she had 5 shirts, or the cost of 5 shirts, so 5x, she still had $10 left, so we had that 5x plus 10. That's also equal to, because that's the total amount of money she had, But it's also equal to 3 times the cost per shirt plus $24. Because once again, that's the total amount of money she had. These two guys are equal to each other. So again, total cost of money she did have enough to buy 5 shirts plus $10. And she also had the total amount of money to buy 3 shirts and still have $24 left. So there would be our equation to solve. 5x, 5 times the cost of shirts plus 10 equals 3 times the cost of shirts plus 24. Okay, we could use that to solve how much the cost per shirt is. Moving on. Jim received notice from his employer that the equation to calculate his salary was changing. Currently, he makes $300 per week plus 4% commission on sales. The new equation will be $450 plus 2% commission on sales. Which equation shows the amount of sales he will need for his salary to be the same? So, I'm going to let S represent let me see. Well, we're going to let S represent sales, or the amount of sales he made. Okay. Well, his current salary, so we want current salary, which could be represented by the equation $300 plus 4% commission on sales. So first we're going to convert 4% to 0.04. So a number we can deal with. I was going to drop the percent sign, move the decimal twice, we get 0.04. And he makes 0.04 on the total amount of sales he makes. So times his sales. Okay. The new salary can be represented with $450, given amount he gets, plus, once again, plus 2%. So let's change that to 0.02. And he gets 2% on sales. Okay. And to better understand that, for example, just to make an example, let's say we sold $100 worth of stuff. Just an example, side note here. So we sold $100 worth of stuff and we get 10% or 0.10 on the sales. What we're going to get is $10. So that's just saying that if he sold $100 worth of stuff and he's getting at 10% of sales, he will get $10 of whatever he sold. Just as an example. Now going back to our problem situation. Which equation shows the amount of sales he will need for his salary to be the same? So we want these to be the same. And when you hear that word the same, it means equal to. So we want current salary to equal new salary. So current salary, of course, is $300 plus 0.04 or 4% of his sales. We want it to equal this new salary of $450 plus 2% or 0.02 of his sales. So there's our equation. And once again, we're not solving, but we could use this to solve how much in sales he would have to do in order to make the same. All right, moving on. Ronald rents a car. Oh, hold on, let me get to writing. Okay. Ronald rents a car from Cheaper Rent a Car for $25 plus 0.05 cents per mile. Once again, there's that keyword per. Dixon rents a car from Great Cars for $40 plus 3 cents per mile. Once again, keyword per. What would be the equation they should use to determine how many miles must they both drive for their rental cars to be the same? Okay, let's let M, the variable M, represent total miles driven. And what we're looking for is Ronald's rental on car to equal, because we want it to be the same. Let's get keyword same. Dixon's rent on his car. Oh, well, Ronald's rent for his car can be represented by the equation $25 plus, once again, plus 5 cents per mile. Once again, we don't know the amount of miles, so I'm just going to represent that with M, total number of miles. Dixon rent can be represented by $40 plus, once again, plus 3 cents per mile. Once again, don't know the number of miles. Okay. We can see that Ronald's is cheaper to rent at the beginning because it's only costing $25. And Dixon's is a little more expensive because it's costing $40. But each mile starts costing more. So once again, we want to find out when they're equal to each other. So we'll just set Ronald's rent equal to Dixon's rent. So $25 plus 5 cents per mile equals $40 plus 3 cents per mile. Alright, so there's our equation. Okay, number 4, Carissa. Once again, let me grab this. Okay. Carissa is going water skiing. She can purchase skis for $125, or she can rent skis for $30 an hour. In both cases, she must rent a safety flotation device to wear that is $5 per hour. Which inequality, once again, inequality, shows the number of hours Carissa must ski for the cost of buying skis to be less than renting the skis. Okay. So let's let H represent the number of hours she's out. Number of hours she's renting or number of hours she's actually skiing, okay? Sorry, it's hard to write. Okay. So once again, what we're looking for the inequality. So less than, greater than, less than, or equal to, those symbols. That shows the number of hours Carissa must ski. The cost of buying, we want buying to be less than renting. So buying less than renting. Okay, well first let's find out how much it would cost her if she was buying. So buying can be represented with the following. Well, it's $125 to buy the skis. But while she's skiing, she has to rent this flotation device for $5 per hour. So plus 5H. Oh, sorry, $5 per hour. So $125 for the ski plus $5 per every hour she's out there for the flotation device. Renting the skis would cost her $30 per hour. So we're going to say H. Let's get H representing per hour. Plus the $5 per hour renting the flotation device. Well, if you combine like terms, 30H plus 5H, you get a total of 35H or $35 per hour. That's what it's going to cost her. So once again, set up our inequality. We want the buying of $125 plus her $5 per hour for a flotation device to be less than the total cost of renting, the $30 per hour plus 35. So $35 per hour. Alright, so there's our inequality. See, I got last one, guys. Okay. Alright, so on this one, Lainey is ordering books while she is on summer vacation. Readers Book Club charges $4 per book and requires a one-time membership fee of $12. So once again, keyword again, per. So $4 per book. So every time she gets a book, $4 more. And requires a one-time membership fee of $12. So that's just a given number. She just has to pay that. When she pays the $12, she needs to start renting books for $4 per book. Perfect Pages requires no membership fee. So it doesn't have to pay anything up front. but they do charge $7.50 for each. Once again, keyword each book ordered. The cost for Laney to order books depends on the number of books ordered. B. Real quick, I'm going to write that down. We're going to let B represent number of books that she's bought or she's ordered. Okay. Which inequality, once again, keyword, we're looking at inequalities now, not equations, can be used to find the minimum number of books that can be ordered so that the cost of ordering books from Reader's Book Club, we want Reader's Book Club, to be less than the cost of ordering books from Perfect Pages. So less than Perfect Pages. All right, well, the cost for Reader's Book Club can be represented with the following. Once again, it's $4 per book. So $4. Again, per book, we don't know how many books, we're going to represent that with B. So $4 times B, depending on how many books she rents. $4 per every one. Plus that one-time membership fee. Plus the $12. Okay, Perfect Pages can be represented with, well, no membership fees, so $0. We don't have to write that down. But $7.50 per book. So $7.50 times the amount of books that she orders. All right, well, once again, Reader's Book Club, we want it to be less than, so we're just going to take her amount, so $4 per book, plus her $12 membership fee. We want that to be less than $7.50 per book. All right. So once again, we're not going to solve, but what she's trying to figure out is she orders, depending on how many books she orders, she wants to make sure she picks the right membership club. So it's cheaper to go Perfect Pages if she's ordering like one book or two books because of that membership fee. But there's a certain point where it'd be cheaper to go with the Reader's Book Club. All right, but that's our equation. Like I said, we're just setting up equations today. In the future, we will be solving these. All right, guys, I hope you enjoyed today's lesson. I will see y'all soon.